Hey y'all, it's Andrew Couch here, and in this TidyTuesday video, we're going to be going over how to create machine learning models using big data. But first, I have a huge announcement. This will be my last TidyTuesday video for the series and will be the end of my regular scheduled content. But I'll kind of talk more about the details towards the end of the video. But first, let's actually open up our Markdown document, and I'm going to call this TidyTuesday Big Data. Right, and we're going to load in a few packages. Is that a few packages? So we're going to load in the tidyverse. I'll make this a little bit bigger. We'll load in the tidyverse, TidyModels, TidyPredict, fine tune for training some models, Sparkler for creating our models using Spark as a backend, and also the DBI package. We're also going to load in our options, and I always do TidyModels.dark is equal to true. And lastly, we can also load in our data set, which is a customer churn data set that we've used in the past for some of my other videos. Okay, so if we look at our customer data set or our customer churn data set, we have a customer ID, some general attributes of the person, some monthly total charges, and whether they actually churned or not. If we actually look at the missing values, so if say is.na, and then we do like a call sums, we can see that there are 11 missing values. So considering that we have about 7,000 rows, I think it's fair to say that we can just drop those missing values or drop the samples with the missing values. So let's actually do some data cleaning. I'm going to mutate across all the columns where the variables are a character. And then I'm going to say as.factor, right? Now everything is a factor if they are a character. Cool. And then lastly, we're going to do the drop NA, and that'll drop these missing values. So we're going to say create, convert features to factors, and drop missing values. I could do a factor thing for the senior citizen, but senior citizen is actually like a one hot encoded variable already, or a dummy variable, so we don't have to do a lot of data manipulations to it. So when we're thinking about big data, we're also thinking about like having a large volume, large velocity, a lot of samples. But one of the main problems when we're facing big data, when we're making some predictive models, is that oftentimes the data that we're trying to use can't fit into memory, which is like the amount of RAM we have. Now we can always set up different environments using like cloud computing and stuff like that. But oftentimes we might want to think about how we can do it like in the database, right? Since databases have a lot of power behind it, and ideally it'd be kind of nice to just have it run in the database instead, so that way we don't have to use it on like our nice little laptops that we have at our office. And there are a lot of ways we can do this. For me, I don't use a lot of big data programs. So like a lot of common ones I think are like Hadoop and Spark. So like I think Hadoop, Hadoop/Hive, and then Spark. But for me, I really don't I really don't face a lot of big data challenges, but I often want to make some predictions in database because oftentimes, we can, if we have a model that's pretty good and we can put it in as essentially a query, then we can have the databases do all the work. We don't have to worry about dependencies with R. We don't have to create our Docker containers or stuff like that. We can just create our query, give it to someone, have them schedule it out, and we can go on from there. So this is the first method we're going to do, which isn't really about big data, but it's about how to make, predictions in database using like machine learning models with the TidyModels framework. So we're going to just do a classic train and test split. So we'll say initial split, df. I'm going to deselect the customer ID, and we'll say strata is based off of churn. And then we'll create our train data. So training model split, and then our k folds data which will be using our trained data. Oops, CV, so trained data. Okay. Now we're just gonna do a kind of a typical run. In this case, when I know that I want to make a model that's gonna be in a database, I'm trying to think about, what are some nice strong models, but also that aren't too large. So, oftentimes when we're thinking about using machine learning models, we want to do like, a lot of tree-based models. But the problem with tree-based models is that, oftentimes we're using like random forest or XGBoost. And like with random forest, we're going to be creating a lot of trees, and each tree is essentially going to be like kind of a query. So that can get very large. So if we have a random forest model being trained to predict a customer churn, oftentimes that model might have like 500 trees, which can actually raise some issues with the query. Since the query can be like, too large and you can run into weird system errors. But that being said, I like to do Mars models when I'm thinking about doing um, a SQL model. So I'll just say num terms equals tune prod degree, or the interaction term. We'll tune it, and we'll say set mode is a classification, and we'll set our engine to be Earth. Right. Cool. And then we have to do a slight recipe. So we'll say rec recipe turn data is equal to train data. And then we'll say step dummy all nominal predictors. Right. So if we do a prep and juice, 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 we can see that it's created our dummied variables, right? And then we still have our stuff. So obviously with most of our numerical variables or our continuous variables is tenure, monthly charges, and total charges. And then we have our other variables, stuff like that. Okay, so now let's actually tune our model. And if we notice, I loaded in the fine tune package, which kind of allow us to do different tuning methods that'll kind of select our parameters for us. So I'll say Mars res tune sim anneal, give it our Mars model, our recipe, our k-folds data, and then our metrics. I'm just gonna say we want to optimize or evaluate our each iteration by ROC AOC. Okay, so now it'll be training, and we should be able to see some little dialogues right here. We'll just kind of wait and see what it looks like over here. And I'm going to do a auto plot and say Mars res, so we can do some pre-tuning. We'll also create some models or some pre-coded stuff right now. So, we might want to do show best Mars res, and we'll see the ROC AOC. And then we'll actually create our final model, which will be this one right here. And we'll just wait just a little bit. So oftentimes I think we hear a lot about big data, but for me, from like a basic, data science workflow, I don't think you actually will see a lot of big data unless if your job is, has that type of data in its field. So, if you're doing a lot of like web stuff or e-commerce, you might have a lot of big data. If you're doing like a lot of streaming or like kind of like tech or video stuff like that, or with sensor data, you'll experience a lot of big data. But for like your generic like, your typical machine learning problems generally won't revolve around big data. And one of the problems with big data is not just the machine learning part of it, but also like how we're going to store it, how we're going to query it, who's going to host it, what's the cost of storing it, and like what actual insights can we get from this data that are useful. Oftentimes when I'm looking at machine learning problems, or if I'm thinking about using models for a project, I'm often not looking for the number of samples in a data set, but mostly the quality of the data in general. So that's another thing that we should really kind of think about, that oftentimes if we have like 3 million or 4 million samples, it might not be as good as like, a 5,000 sample data set with like great quality control on it. We have nice like the data is sanitary. People are putting in all the inputs from like a reasonable standpoint. So that's one thing that we need to consider when we're doing stuff with big data, or even thinking about doing stuff with big data, is understanding kind of the source of that before we actually start running an analysis. So we can kind of plot out our model metrics. So we can see that the degree of interaction is 1, and that's slightly higher. You can see that it's almost like an intercept, where we're getting higher ROC, AOC performance. And we can see that the number of terms have increased, and we can be comfortable with using 5. So we can do that, show best, 5 terms with a product degree of 1. Let's actually look at this. So we'll do 5, 1. And one of the reasons why I'm not creating a workflow is that we want to actually do some pre-processing with it. That way we can actually look at this in a database, because oftentimes we're not going to be able to use our pre-processing inside the database. So let's actually fit it to our churn. Data is equal to rec prep juice, and also use the VIP package to do the VIP, right? So we can see the tenure, internet service optic, and payment method check are the important variables that we see right now. Lastly, we can actually do a workflow just to evaluate on the test set to see how it performs on our test set, or the data sets that we haven't seen. So add model, and I'll just copy this thing in right here because it has the best parameters. We'll add the recipe, which is the rec, and then we'll say last fit. I think we called it model split, and we'll say collect metrics, right? So we can see our ROC AOC is 0.80. I think our original one was 0.83. So we have just a little bit less in the number of terms, but that's fine. This is just kind of an example. So we're not really working over like how to tune a model, since I've made plenty of videos on how to do that. But now let's actually think about, say we have this model, and it's good. We know that it's a pretty easy model to build out because it's using 5 terms. There's not a huge amount of interactions. We don't have a lot of features that we're going to be using. So we can actually create this into a model, or a SQL query model very quickly. So when we have our fitted model right here, we can actually just pipe it in to TidyPredict. And in this case, we'll do TidyPredict SQL. And then what we can do is we can do the, dbplyr, which is included in dplyr. And we can just simulate whatever backend database we want. I think I'll just do MS SQL. I think MS, or no, it's MySQL. So MySQL is, I think, the most like bare bones SQL that you can use. And right there, since we know that Mars models are just like kind of like spline models, they're pretty easy to actually write out or convert to a SQL script. So we can see right here that's doing it. It's just a bunch of case statements, but let's actually see that in practice by creating a little database or a little table, and making our using our query to actually test the model, or the SQL model. So we'll say db connect this from the dbi package. I'll use rsql, rsql lite, and then we'll say SQL Lite, and our DB name, DB name will be in memory, right? So we're just saying we're going to create a table in memory that's going to act as our database. And then what we'll do is we have our data frame right here, which is the one that has no missing values, but wasn't like the train and test split. We'll actually do is a copy to, we'll give it our connection and then our data frame. And now we have our data frame as a table into memory, which is going to kind of simulate what it's like to be, what's going to simulate, it's going to simulate what we're going to do for our database. So I'm going to actually expand this up. And then we'll type in SQL. Connection is equal to con. And if we do a select star from df, we can see our data frame is right here. and it's fine and dandy. So if we look at this query right here, we can see that there's a few things. Like it's saying payment method electronic check, and that's essentially a dummy variable. Because if we look at our variables that we're using from right here, it's tenure, internet service, and payment method. So let's actually do that. So let's say, was it internet service and payment method and tenure. We'll also select the customer ID, and then we'll say also churn, right? So we can see right here, it's, we need to do some manipulation to it. Luckily, that's pretty easy. It's just a bunch of case statements. So, this is where we can brush up on our SQL and do our little service right here. So we'll say with internet service, it's saying fiber optic, right? Fiber optic. Yep. We'll just do a case statement right there. So we'll say case when equals fiber optic, then 1, else 0, and as, and we'll give it whatever the name is for the internet service fiber optic. Cool. And actually, I think it might be, let's see, let me count. Oh yeah, it's right there. So fiber optic. So it has a little dot that'll replace the space. So we have that, and then we'll also do the payment method, right? So case when payment method is equal to what's the payment method? Payment method equals electronic check. So electronic check, then 1, else 0, and as internet service. Where is it? And as payment method electronic check. Oops. And we'll actually make that into a little column. So we have that. And finally, we can just do a little select star. So select from, or a little subquery. We'll say select from, and we're going to be selecting from this other query right here. I'll give it an A, and then we'll copy and paste this just to test it out. Right, so we have that, and then we'll say churn prob, and we'll also select the customer ID. Okay, so now we have the probability of churn with our customer ID using our SQL model. So I'm going to call this, say, output.var is equal to SQL pred. Now we have our SQL pred. SQL pred. And let's actually create our final model. So we'll just say, where is it? Where is it? Where is it? Oh, there it is. So we'll fit that. Right. And then we'll also augment it to our whole data set. So we'll just say, we'll use a recipe to process our data. And we'll also bind our columns where we'll select the customer ID. Right. And then we'll select the customer ID. And we'll select the .pred yes. So .pred yes. And we'll say this is the Mars model. And we'll left join our SQL pred by customer ID. Right, customer ID. Cool. And we'll rename to SQL model is equal to churn prob. So just a basic amount of data manipulation, but I want to kind of highlight kind of an example of sometimes the actual model, the SQL model, will be slightly off. So if we have our Mars model, our SQL model, GM, we'll just do a GM point. So what I want to do is plot the actual direct comparisons. So GM add line, which would be our little y equals x line. And we'll also do the chord equals observed versus pred. We'll see that this line, or the SQL model, is not meeting it perfectly. In fact, you can see that the slope of it is actually pretty off. And that's the one that's actually a huge problem with, converting these converting these machine learning models into a SQL script is that, we only have case statements and stuff like that. We can't get super fancy, and sometimes it doesn't translate perfectly, especially with like classification models and stuff like that. But what we can do is actually do a minor adjustment to it. Also, I think changing the back end. So in this case, we're using like MS SQL, but you can also change it to like, we're using MySQL, but I think you change to like MS SQL, it'll actually kind of fix it. So it depends on your back end. So you might not have to change anything, but it's also good to kind of make these plots to compare what your SQL model is doing with compared to your true model or your true like R model. But this is a very easy fix. What we can actually do is that we can select this. And right here we can think like, oh, hey, we can just like change the slope of it, which is, just a minor adjustment, just a linear regression, right? So let's do that. So let's predict the Mars model probability using the SQL model. And then we'll say data is equal to dot. And then we'll augment it out. And then we'll see the actual adjustment. So x equals Mars model, y equals dot fitted. Oops. And then we'll say GM point plus GM AB line plus chord OBS pred. And we can see that it's been adjusted pretty well. So it's not perfectly one-to-one, but it's good enough, right? So, might have to do some more probability calibration, stuff like that. But in general, this is a pretty quick model that, we can do a minor adjustment to it and do pretty well. So what I'm going to do right here is actually get the coefficients from it. And let's actually go into what we would do to adjust our SQL model query. I'm going to grab this, right? And I'm just going to kind of show off some of my SQL that I know from like school and stuff like that. So what we're going to do is do a with statement. So with, we'll say, I don't know, data as, and we'll select this. And then we'll say model data as, and we'll select that. And that'll be from DF. You don't have to do that. From data. So I'm basically creating this subquery right here. And then I'm creating another table that's going to be using this created query. So I'm creating a query right here. And then I'm creating another table to query from that query. And then I'm going to do just a sanity check. So I'll say select star from model data. Right. So we have that. And then finally, we can do like adjusted pred as that. And in this case, we can select the model data. Right. So we'll say churn prob. And then we'll also do a little adjustment using this linear regression. So plus churn plus, so the intercept plus the coefficient times churn prob. And we'll say as adjusted prob. And we'll also do customer ID. Customer ID from churn prob. Oh, and then we'll do select star from adjusted pred. Right, so now we have our adjusted prob right there. Right. And we'll call this output.var equals SQL adjust. Because why not? Okay. So now we have our SQL adjust. And we can do a little sanity check right here. So we'll just get this thing right there. Right. And we'll left join. And we'll say by customer ID. And we'll pivot longer. And this is, we'll do the, actually we'll do some renaming first. just to make it cleaner. So rename old, I'll say non-adjusted prob is equal to churn prob. And then we'll pivot that, just make it tiny or tidy. So adjusted prob and then adjusted prob. And finally, we'll plot it out. So just do a quick ggplot. Point. Right. So then we do, what's your color y equals value? What's going on here? Let's see, Mars model. Okay. And you can see how we came from this to there. So we kind of spread it out, which we did a little minor adjustment. Again, nothing too crazy. Pretty fast adjustment right there to make our model, the probability is a little bit more situated. For me personally, I would probably just run like logistic regression and just do adjust it through that instead of doing a linear regression. But it depends on your data and stuff like that. But that right there is a pretty quick way of creating a quick model, putting it into a query, and then evaluating the query to see how well the SQL model is compared to the old model, and then putting it into like a database or giving it to some type of like SQL developer and scheduling it out. Okay, so that is just that's not really big data. I'm sure most of you guys wanted to do big data stuff, like how can we actually fit a model using the cool flashy things like Hadoop, Hive, and Spark in database, so we don't have to worry about any of this stuff. Luckily, I found the Sparkler website. So what we're going to do now is actually create a simulated Spark like database, I guess, or what is that, a cluster? So we'll say SC Spark Connect master equals local. If you don't have Sparkler installed, you may need to actually have this in there right there. So I just copy and pasted that in there, which will install like an instance of Spark. But again, it's pretty straightforward right there. Okay, so in this case, we're going to create another thing where we're going to create our table. In this case, we have to do a churn table and say copy to SC, and we'll give it our DS or DF. And if we look at our churn table, it's a Spark connection. We can see our little churn data set right there. And let's actually go and do some, data manipulation, or show you how to make like essentially a pipeline for creating your Spark models. So right now with our churn table, I'm gonna do a few things. Let's just do like our, I don't know, like internet service. Maybe I could do maybe I'll do this quickly. Yeah, let's actually do it. Okay. So I'm gonna just do a brief, kind of like a p-value approach to a GLM. So I'll say, train data, right? And we'll say a GLM churn data equals rec prep juice family is binomial, and we'll tidy it, and then we'll say like filter like p dot value 5. So now we have our things right there. This is something we'll just do. Not I just felt like we'll create like a random forest model, but we use like a p-value to do the feature selection, even though obviously random forest can do it for us. But so what we want to do now is say, what are the things that we need to change, right? So right now we have our churn table. We want to do our contract year. So let's see what our contract year looks like. Where is that at? Contract. So we'll say mutate. We'll say contract 1 year is equal to if else. So contract is equal to 1 year. Oops. 1 0. So in this case, what we have to do is actually do like the dummy variables itself. I've looked at it a little bit on like the things that we can do. So there's like a binarizer threshold to a column such that less than or equal, bucketizer It does cuts, but I don't think I really saw maybe there's a dummy thing, but I feel like all these are stop words and stuff like that. So we'll just do it manually right now. So we'll do our 1 year. We'll also do our 2 year. So we'll copy that and say 2 year. So if it's equal to, I guess, 2 year. Okay, so 2 year. And then we'll do paperless billing. So paperless yes is equal to if else. And where's paperless billing at? What's it called? What paperless billing? Oh, there it is. Paperless billing is equal to yes 10. And lastly, we'll do, I guess, payment method. So payment method is equal to, or if else payment, we'll say payment electronic. Payment electronic. So if else payment method is equal to what's electronic check. We'll give it a 1 and 0. Okay. And then we'll have to select the thing. So select churn, senior citizen, tenure, total charges. Forgot multiple lines, so we'll do that again. We'll say multiple lines, yes, equals if else, multiple lines equals yes 1 0. Okay, cool. So we have our tenure, total charges. We'll do our multiple lines, yes. Our contract 1 year, contract 2 year, paperless, and our payment method electronic. Yay, let's see here, what's going on here. Now our pay method electronic. Oh, right there. Okay, let's see here. Select payment method. Okay. Oh, there we go. Okay, so we have that, which is essentially like the transformation that it's going to do, because this is very easy to transform this like dplyr syntax into like a SQL thing. So what I always call is like, we'll call it Spark dplyr, right? And what we can kind of see is we can actually convert this transformation or these like features, stuff like that, into our transformer. So we'll say our source and we'll say our Spark dplyr, and it kind of shows that right there. And if we say ML param, which is like the helper functions, we can say statement, and we can see what it's doing, where it's creating the that SQL right there. Okay, so now let's actually go on to kind of creating our model or our model pipeline. This essentially right here is our recipe, and now let's actually put it together and create like a workflow. So we'll say ML pipeline. We'll give it our source. We'll say our we'll fit our dplyr transformer, and our table, our table, I guess, will be this function right there, and then we'll say fit our formula. And in this case, I like to kind of just copy this in right there, give it a tilde, and then we'll just do a search and replace. Oops, not that. A search. So we'll say that, and we'll replace it with that, I believe. Cool. We have that right there. And then we can fit our model, I believe. So we'll say ML, and then we can say random forest classifier. And this will be our Spark. We'll call it our churn pipeline. Sweet. And if we look at our churn pipeline, it kind of gives us a nice little like, I guess, workflow. It's a more complicated recipe of it, but That's our pipeline right there. What we can actually start doing is creating our tests and train and test splits. And that's kind of useful because, why wouldn't you just query it, do a select star from the churn table, and then partition it like that? Sometimes, you can't store it in memory in our laptops. So oftentimes we might want to put it into our database. So we'll call it our Spark split. And then we'll say SDF, which is like our Spark function. And then we do the random split. We give it our churn table, which is churn table. We'll give it our training, which is 0.8, and our testing, which is 0.2. And now we have our Spark split object, and it returns our train and test tables, which is very nice. And finally, we can fit our model. So we'll say our Spark model. So we'll say ML fit. Give it our pipeline, which is our model, our preprocessing, our deep wire transformations, the formula, the model we want to use, and then our data set. So in this case, we obviously want to use our train data sets right there. So now it's fitting the model. And finally, we can actually go and make our predictions on our test set. So we'll say Spark pred, and we'll say ML transform, which essentially is saying like, hey, we have this data set or table, and we're going to pass it to the pipeline and transform it into our thing that we want to get out of it. So we're going to give it our Spark model, and then our Spark split with our testing data set. And now we have it. So what I would want to do is select the probably customer ID. What was it? Customer. What was it called? It's a. Yeah, we'll just look at it. Right. Okay, so it's gonna pop up. See, it actually takes a little bit because there's a lot of stuff that goes into it, but we have our churn, so we'll say we'll select our churn, and then our probability. Did I not put the oh yeah, oops. Oh well. Right, churn table. Our churn table should have it, right? Oh yeah, I forgot to add the customer ID into this, so obviously I want to put this right there. That way it'll keep the customer ID in there. So we'll just do that again, which is fine. Right, so we do that. Right, because like when we're passing in our our deep wire thing right here, we didn't select customer ID, which is something that's probably useful, which is why we have like our transformation, which is like our select statements, and then our formula where we can like basically not put in our customer ID because that can cause some problems. Did I pass the transform? So we can look at that. And then we'll probably do a customer ID. Yep, so we have our customer ID. Oops. Customer ID. And then lastly, we'll use collect, which is going to basically do the actual query. So we'll say like, we'll call it like, I don't know, res. Right, so res. So that way we're basically saying like predict on, given our given prediction, we're going to actually query it and get the results as a data frame in memory. And ooh, actually I forgot to select the prediction. So let me do the prediction. Right, so we can see how we have our churn, our result, our customer ID, and then the probability of it being churned. And then the actual probability gives it in like churn or no churn. So we can say map DBL probability, and it's pluck, was it 2, right? And right here we can see that we have the probability of churn. Since the prediction is 1, we see it's above 50%. That means it's like yes, the probability of of a churn, probably of no churn, is a low probability and stuff like that. So yeah, as you can see, it's actually very easy to create your models in Spark, given this type of memory data set. So oftentimes you'll have to do a bunch of joins and stuff like that. I'm not going to go over deployment because I don't know how you would do it with like your given system. You probably have to save the file and stuff like that. But what's really nice about these types of pipelines right here is that you can just run it on anything. You can put it, probably on your setup. You can refit it pretty easily. You can just save this pipeline and then just fit it to whatever data set you have, or like from maybe even a refresh table. So you can like schedule that like off hours, stuff like that. So again, it's a very straightforward package. I personally really like using the TidyPredict. It's very fast and you can kind of make adjustments. It's also very useful when you want to do like a Tableau dashboard and stuff like that. Um, so yeah, this will conclude the Tidy Tuesday series. I really enjoyed making these videos. Um, the main reason why I'm not making more videos or not making more like regular scheduled videos is because I think I've kind of hit my ending where I've taught everything I wanted to teach. This was basically the last thing I wanted to teach. Um, and I figured I would kind of not overstay my stay onto YouTube, but I really hope you guys enjoyed all my videos. I'm still gonna be kind of active. I want to do more project related videos, but that won't be at a consistent schedule. Um, so with that being said, I hope you guys had fun with my YouTube channel and tidy on.